Power factor correction has been around for a long, long time. Do you know why? With power factor correction, you can avoid utility penalties, you can free up more capacity in your electrical system, and you can stabilize voltage tolerances. Power factor penalties are hidden in the utility bill, and today we're going to take a look at how all three of these things can be accomplished in this episode of The Power Grid. Hello and welcome back to The Power Grid, a podcast to help you build reliability in your electrical system and gives you confidence in your power. I'm Brian Brannigan with Power Protection Products. We've been solving power quality problems for almost 30 years. We are your trusted advisor for critical power, cooling, and energy solutions. Power factor correction can not only reduce utility penalties on some utilities, in many cases, the right correction can produce utility credits on your monthly bill. Power factor correction can also free up additional capacity on your electrical system and help stabilize voltage tolerances when applied to the right type of equipment. Imagine a factory that had been there for a long time getting billed for the utility that it uses from the electrical company. And the utility company implemented a power factor penalty tariff that nobody knew about at the company. The utility bill just continued to increase a little bit at a time, and nobody noticed it because the utility bill was going directly to the accounting department. Well, utility companies can change tariffs all the time, particularly when they're at capacity or getting ready to build a new power plant. So power factor correction penalties or power factor correction charges are not unusual for utility companies. But what is unusual is for the factory that's getting penalized to notice these penalties in a way that they can actually avoid them. So it's important to go back to your utility bill, see if your utility company is charging you for a power factor penalty, and take the right course of action to correct it. Why power factor correction? There's a variety of reasons for correcting power factor. Utility penalty avoidance is a great reason. It can also add KVARs to your electrical system. First, let's define how this is done. A magnetic field is needed for electricity to flow. And this magnetic field can be supplied by the utility company, or it can be produced by the facility itself. Electrical utility distribution equipment needs to be sized or oversized for the magnetic field on the grid. But you can buy power factor correction equipment or capacitors to take care of this. So the first reason for power factor correction is to reduce or avoid penalties on your utility bill. This applies only if your utility company penalizes you for power factor. Many utilities do, and many more utilities will start to do this as they get to capacity in their system. Some utility companies will even provide a utility credit on your bill for the correct power factor. It's important to look at the utility tariff for the rate class associated with the facility and see if these tariffs have changed and how they impact your utility bill. Sometimes these changes go right to the accounting department, and the increase is just absorbed in the cost of doing business. Now, many power factor correction projects that we work on have a less than 2-year payback. It's a matter of sizing the power factor correction equipment, placing it in the correct location, and programming and setting up the equipment. And also understanding the influence that this injection of KVARs will have on the utility meter. There's a variety of purchasing options for power factor correction that can impact this payback. Another reason for power factor correction is to utilize the available current carrying capacity on an electrical system. Raising the power factor when you have an inductive loads will free up system capacity for additional loads. The same principle holds true for reducing reactive current on overloaded facilities. Adding power factor correction capacitors is more cost-effective and a lot less disruptive than adding service entrance additions onto the facility. I'll give you an example. Say that you're using 1,000 kilowatts divided by a 1,500 kVA or kilovolt amps. Our kilowatt divided by kVA would be a 0.6 power factor. So you're using 1,000 kilowatts, 1,500 kVA, and you have a power factor of 0.6, which, by the way, is very low by industry standards. You might run into something like this in a printing operation or a sawmill or something that has a lot of motors or a lot of transformers. Now, if we increase the power factor to a 0.95% by adding capacitor banks, we can reduce this kVA from 1,500 to 1,050. Now, 1,500 kVA on a 480 volt three-phase system is the equivalent of 1,800 amps. But because we added power factor correction or capacitor banks, now we have 1,050 kVA on a 480 volt three-phase system, which is only 1,200 amps. So that's a difference of 600 amps that can be used by that electrical service by just adding power factor correction. Now, a third reason for power factor correction is to help support nominal voltage regulation to a more tighter tolerance. There's voltage stabilization and also raises the voltage closer to nominal. When power factor correction equipment is placed at the point of use, particularly on a fixed application, such as a motor load, this will help reduce the system losses and provide less stress on the electrical system. So to recap, the three reasons for power factor correction are the utility penalty avoidance and our possible credit, utilized entire system capacity better, and stabilizing the voltage tolerances in the electrical system. Thank you for joining us today on the Power Grid. Power factor correction can benefit your facility in three ways. 1, by reducing the power factor penalties. 2, by freeing up system capacity. And 3, by stabilizing voltage tolerances. It's important to use the right power factor correction equipment in the right place in order to get this accomplished. We're here to help. Check out the link in the show notes to learn more.